Every plate of fish on your table, every coral reef teeming with life, every seabird that dives into the surf, they all depend on something you can't see. It doesn't glitter like the surface of the sea, and it doesn't crash on the shore. It's silent, invisible, and unimaginably powerful. It's the ocean's beating heart, a secret network of underwater currents that carry life itself around the planet. But today, that heart is beginning to slow. Welcome to Strange and Curious Planet, where we uncover the mysteries that shape our world. Before we dive into the depths, make sure to subscribe for more stories about the hidden forces that keep Earth alive. The hidden conveyor belt of life. Far below the waves, stretching from the polar seas to the tropics, flows something scientists call the global ocean conveyor belt, or the thermohaline circulation. It's not a single current, but a worldwide system of water movement driven by temperature and salt. Thermo for heat, haline for salinity. So here's how it works. Near the poles, icy winds cool the surface of the ocean and the water becomes dense and heavy. As sea ice forms, it squeezes out salt, making the surrounding water even saltier and heavier still. This cold, salty water sinks to the ocean floor and starts to flow southward, beginning a slow, deep water journey all the way around the world. As it moves, it actually pulls warm surface water from the tropics northward to replace it, forming a massive continuous conveyor belt. This process redistributes heat and nutrients, moderating the planet's climate and fueling the ecosystems that feed billions of people. It's a system so vast it takes about 1,000 years for a single drop of water to complete one full circuit. Without it, Earth would be, well, almost unrecognizable. The tropics unbearably hot, the poles even colder, and much of the ocean barren. Most of the world's fisheries, from the sardine runs off South America to the cod banks of the North Atlantic, exist because of upwelling. That's when cold, nutrient-rich water from the deep ocean rises to the surface. Those nutrients, like nitrogen and phosphorus, act as fertilizer for microscopic algae called phytoplankton, which form the base of the marine food web. The conveyor belt helps trigger and sustain these upwelling zones, feeding fish, plankton, and all the creatures that depend on them. Peru's anchovy fisheries, for example, thrive thanks to the cold Humboldt Current, part of this larger global system. The same is true for California, Namibia, and the coast of West Africa. Entire economies and cultures built on the movement of invisible water. But that delicate balance depends on one thing: the contrast between warm and cold, salty and fresh. And climate change is starting to erase that contrast. Over the last few decades, satellites and deep-sea sensors have recorded a disturbing trend: the thermohaline circulation is weakening. The main engine, the Atlantic Meridional Overturning Circulation, or AMOC, has slowed by nearly 15% since the mid-20th century. Why? Well, because global warming is melting ice sheets in Greenland and Antarctica, pouring vast amounts of fresh water into the ocean. Fresh water is lighter and less salty, which means it doesn't sink as easily. Without sinking, the conveyor belt stalls. This slowdown isn't just a local issue. The AMOC helps distribute heat that keeps Europe's climate mild. Without it, winters could grow far harsher, rainfall patterns could shift dramatically, and tropical regions might face even more intense droughts and heat waves. But perhaps the most immediate impact will be on the ocean's ability to feed us. If the conveyor weakens, deep water won't rise to the surface as it used to. That means fewer nutrients and fewer phytoplankton. Scientists already estimate that plankton populations have dropped by up to 40% in some regions since 1950. That's a silent collapse at the base of the food chain. Less plankton means fewer fish, fewer whales, and less oxygen production, because plankton generate half of the oxygen in Earth's atmosphere. If the conveyor stops, it's not just fisheries that die. The very rhythm of life on this planet changes. Even coral reefs far from the poles could suffer. Warmer surface waters and reduced nutrient flow make them more vulnerable to bleaching, while changes in currents could disrupt the migration of fish species that reefs depend on. This isn't the first time it's happened. Around 12,000 years ago, near the end of the last ice age, a sudden surge of fresh water from melting glaciers shut down the ocean conveyor in the North Atlantic. Within decades, Europe plunged back into near-glacial conditions in an event known as the Younger Dryas. It took over 1,000 years for the currents and the climate to recover. Scientists fear we could be approaching another tipping point. The solution lies not in the ocean, but in us. Reducing greenhouse gas emissions, restoring coastal ecosystems, and protecting polar regions can all help slow the warming and melting that threaten this delicate system. Projects that monitor deep-sea salinity and temperature, like the Argo network, give scientists real-time data on how close we are to the edge. But the clock is ticking. Once the conveyor collapses, restarting it might take centuries, if it happens at all. When you stand on the shore and feel the waves, you're really feeling the surface of a living machine, one that has fed humanity for millennia. The ocean is not just water, it's motion, memory, and life itself. If we let that motion stop, we don't just lose the fish, we lose the planet we know. So next time you look at the sea, remember, beneath that calm surface, the ocean's secret current still flows, carrying the breath of the world. And right now, it's asking for help.